In this section, we're going to be dealing with some more with the identities, and it's the same identities that I gave you in the previous section, which are the three that I have listed here. So the reciprocal identities, ratio identities, and Pythagorean identities. So you'll want to pull those notes back out from the previous section where you had written down all of those identities and have those handy to refer to. Alright, first problem that we have here. Sorry, I'm going to adjust this screen just a little bit. Alright, first one that we're dealing with here, of course it states to write in terms of sine theta only. Alright, so you're going to rewrite cosecant theta so that it's only expressed with only the trig function of sine. And this one's just a very simple one-step problem to be able to do. It's using your reciprocal identity, and that would be that cosecant theta is equal to 1 divided by sine theta. So that would be your answer, because like I said, you're just simply rewriting it, but it has to be in terms of sine. Okay, so that's, again, just your reciprocal identity. Alright, the next one. Here you're told to write in terms of cosine theta only. Okay, so actually I'm starting out with cosecant again. Alright, what you can do in this case is actually start out the same way that I did just a minute ago, and let's take this to 1 divided by sine theta. Okay, of course it's supposed to be in terms of cosine, so we're going to have to go another step here. Alright, so if you would refer to your Pythagorean identities, what I'm going to do is look for the Pythagorean identity in which I have sine theta equals, so I'll just pull it back up here. That's actually going to be this one right here. I can replace the sine theta that I have in my denominator with that identity right there. So this would now be equal to 1 divided by plus or minus the square root of 1 minus cosine squared theta. So that would be the answer to this problem, because you have rewritten cosecant theta in terms of only cosine. Okay, next. Alright, so write each in terms of sine theta and cosine theta, and then simplify. Alright, so we're working towards sine and cosine both. Alright, what you would want to do first, of course, these three are just being multiplied, so them being side by side indicates multiplication. So I'm going to replace secant with 1 divided by cosine. So that's the reciprocal identity, times. Now you've got a couple of options for tangent. Of course, I just finished using reciprocal to rewrite secant. You wouldn't want to use reciprocal to rewrite tangent, because that would be 1 divided by cotangent, and that's not accomplishing what our instructions are telling us. We want sines and cosines. So you're going to rewrite tangent using the ratio identity. So let me pull that back up here. So your ratio identity states that tangent theta is equal to sine over cosine. So that would be the substitution that we need to do here. Okay, next I have cosecant, and I can use the reciprocal identity there and replace that with 1 divided by sine theta. Now you have three fractions here that are being multiplied, so there's some cross reducing that you can do. So for instance, your sine thetas are going to cancel out, so that leaves you with just 1 times 1 in your numerator. And in your denominator you have cosine times cosine, which is going to give us cosine squared. So when you multiply trig functions, it's very similar to just multiplying variables. For instance, x times x is x squared, so cosine times cosine is cosine squared. So back to your instructions where it says write in terms of sine and cosine. You don't have to end up with both of those in your answer, just as long as you don't have anything else except sine and or cosine. All right, the second one here. Okay, same instruction, so we're working toward having everything in terms of sines and cosines. So you would replace cosecant using the reciprocal identity. That would be 1 divided by sine theta. And then cotangent, you'd want to use the ratio identity. So similar to what I did with tangent just on the previous problem, your ratio identity for cotangent is cosine divided by sine. Okay, now we need to simplify this. Now, I showed you a little shortcut back in an earlier lesson, when you have a fraction divided by a fraction. Remember, you can multiply the very top times the very bottom. So, of course, 1 times sine will give me sine. So that's going to be your numerator. And then we need to multiply the ones that are in the middle. So I do sine times cosine. Alright, now there's some simplifying that you can do here because your sines will cancel out. And you have 1 divided by cosine. And that would be your final answer. Now, 1 divided by cosine theta is equal to secant theta. That's the reciprocal identity, but you're not going to want to do that because your instructions specifically said sines and cosines. Alright, so here's a third one. Same instructions. We want everything in terms of sines and cosines. Alright, so the first one I have cosecant, so again use your reciprocal identity. So that would be equivalent to 1 divided by sine theta minus, and use the ratio identity for cotangent, so that would be cosine divided by sine. And then we multiply that times cosine. Like, I would not change anything about this because I'm wanting it in terms of sines and cosines. Okay, I have subtraction, I have multiplication. So actually what you would do here would do the multiplication. I mean, this is just order of operations, multiply before you subtract. Okay, so when I go to multiply, okay, you multiply across the top, so cosine times cosine is going to give us cosine squared. And then sine times 1 will give me sine. Alright, now you can do your subtraction, and this one is set up nicely for you because you do have a common denominator, and we're actually going to learn in a little while, if you don't have the same denominator, then how do you do a common denominator with trig functions? So we will discuss that, like I said, in a minute, but this one's already for us, set up for us. So you just transfer, whenever you do get a common denominator, then that just follows you along. So we're going to subtract our numerator, so that would just be 1 minus cosine squared. Now, I do have this one in terms of only sines and cosines, but if you look back at your instructions, not only did it say to write in terms of sine and cosine, but it also said to simplify. And this one has a step of some simplification that we can do. If you look back at your Pythagorean identities, what I'm going to do is actually replace this 1 minus cosine squared. Okay, so here's the Pythagorean identities. And see, right here is the 1 minus cosine squared, which is equivalent to sine squared. So I can replace my numerator with sine squared. And then there's some reducing that I can do. Like I said, when it comes to working with your exponents here, it's just like variables. Like if this were x squared divided by x to the first, you know, you would subtract your exponent. So you do the same thing here. Or you could look at it this way. This sign that's in your denominator will cancel, but it's only going to cancel one of these on the top, which means you would still have a sign left in your numerator. So this is actually the simplified answer. Okay, so make sure, even once you get it to sines and cosines, there may be some simplifying that you can do.